Hi, I'm Mark Needham with StarTree, and in this video we're going to learn about segment thresholds in Apache Pinot. The segment threshold determines when a segment is committed in real-time tables. So when data is first ingested from a stream, it gets stored in what we call a consuming segment. And the data in a consuming segment is only stored on the disk of the server or servers that are processing that partition. And at some point, the segment will be committed and written to the deep store. And at that point, any other servers can pick it up. And we also have a copy if we need it for backup. And the segment threshold determines when that happens. So why does it matter? Well, we want our segments to be a reasonable size. If they're too small, then we'll get a higher latency when processing queries. And if it's too big, then the server might run out of memory and we might have a lag when we're catching up after a server restart. So let's start by creating a Kafka topic that has 5 partitions. So we're going to use the Kafka topics command to do this. And we're going to pass in the bootstrap server, the number of partitions, and then the name of the topic. So in this case, events, and then finally the create subcommand. And if we run that, you can see after a few seconds, we get a message that says, hey, I've created that topic. Now let's have a look at a data generator. So what this script here does is it generates a timestamp, an ID, an account, and then it prints out a JSON structured message. We can also put in an optional sleep command. And so we're going to call this, and we're just going to set the sleep to 0. We're then going to pipe it through JQ. So it's going to take the JSON message and it's going to convert it into a key value structure, which will then pipe into the KCAT tool using the producer mode, and that's going to get it into Kafka. And so we can run that, and we'll leave that running on that tab. And now we're going to have a look at how to go about controlling the segment threshold in Pinot. So there are 2 ways to do this. The first one is what we call row threshold. What this means is that we want the segment to be committed when it has a certain number of rows. So let's have a look at how to do that. So first of all, we're going to create a table, and it's going to be called events_RC for row count. And this is the schema. So it has a UID, a count, and a timestamp. And now let's move on to the table config. So remember, the table name and the schema name need to be the same. We're specifying a real-time table. And then if we come down a little bit, we can see under the stream config, we are specifying some configuration parameters under flush threshold. And so what we've got there, you see we've got a real-time segment flush threshold rows, and that is set to 500,000. And so what that means is that's the number of rows that are going to be in segments on this server. So it doesn't necessarily mean it's going to be 500,000. In fact, it's actually that number divided by the number of partitions that have been assigned to the server. So in this case, it's going to be 5 because there's 5 partitions in our Kafka broker, and so that means for that particular topic, and so we're going to get 500,000 divided by 5, so it's going to be 100,000. But if we had only one partition, it would be 500,000. We're also specifying a threshold time, and so what that means is that if the rows weren't met after 1 hour in this case, then it's going to commit the segment anyway. Let's now create the table. So we're going to call the add table command. We're going to pass in our schema file and our table config file as well, and then finally the controller host, and let's execute that command. So give it a few seconds and we get a message saying that it's created the table. Now what we're going to do is have a look at the size of the segments in this table. So we've got a tables and then the table name, and then there's a size command that we can call, and we'll pass in detailed equals true. And so if we run that, you can see we get this kind of quite complicated looking structure, but underneath real-time segments, we can see we've got each of the segments. They've got a reported size, an estimated size, and then we've got the servers that have been assigned each of the segments, although in this case there is only one server. Now let's tidy that command up. So just to pull out the segment name and the disk size in bytes. We'll just write a command to do that, and we'll get the first 5. As you can see here, we've got a few different segments. Let's copy just the first one, just grab that name so we can zoom in and have a look at the metadata of that segment. And so we can do this by calling the segment metadata API. And so you can see here, we now get a bunch of information about that segment, including the flush threshold that it was trying to achieve, as well as the actual number of documents that are in this segment. And you can see there's some other information as well. Now what we're going to do is we're going to tidy that up. So like we're going to put it all into a Python script, and we're going to get the list of all the segments for our table, and then we'll go and look up the metadata for each of them. So this is just a script that puts all that together and then prints it out. So we're going to get the metadata, including the threshold, the number of rows, as well as the actual size itself. So let's now run that. So we're going to call that analyze segment script, and then we're going to pipe it through JQ so that it will put it into a nice table for us. And so if we run that, you can see here we've got lots of different segments. The disk size varies a little bit, but you can see that the threshold and the row size are always 100,000. So that's cool. So it's working so far. Now, the second approach to controlling the segment threshold is that you fix the segment size. And so this time, Pinot will try to create segments that are as close to that specified size as possible. We're going to use the same schema, so we're just going to have a look at the table config here. This time, we need to make sure that we set the threshold rows to 0 so that it will fall down and use the segment size instead. And this time, we've set a segment size of 20 megabytes. Usually, the segment size would probably be about 300 megabytes, but just for the sake of this video, we're going to set it a bit smaller. Now, let's call that add table command again. This time that we're going to pass in a different, the schema is exactly the same, but it's in a different file, so that it has a different name. So in this case, it's events_seg, and then the same for the table config, and then we can execute that. And you see we get a message saying we've created the new table, events_seg. Now let's update our analyze segments command to call event_seg, and we're also going to wrap it in a watch command so that it will refresh every couple of seconds so that we can see what's going on. And so if we watch it, we can see that it starts off with a threshold and a row size of 100,000, and the size on disk is 3.9 megabytes. The next time it goes, the next segment that gets committed, it's gone up a bit, so it's now 150,000 and 6 meg. Then the next one, it's 225,000 and 9 meg, and you see it keeps on creeping up. And then we sort of seem to settle, so we kind of get around just above 500,000, and that seems to be sort of around the 20 megabyte mark. And so it'll keep on kind of fiddling around, but that's sort of the range that we're going to end up in. And so that's the end of this video in which we've learnt about the segment threshold in Apache Pinot. Give it a try and let us know how you get on, and I'll see you in the next video.